Okay, this is a review for those of you who still are quite shaky about moments, okay? So first of all, we know that moments is a turning force, okay? So when you open a doorknob or when you open the tap, okay, or when you push open a door, okay, that's a twisting force. It's turning, okay? It's rotating something in order to produce work, okay? So moments is the turning force. And how do we compute for moments? It's force times the distance from the pivot. And force usually is in newtons. Distance is in meters. Okay? So the unit is Newton meter. Okay? So the unit of moments is Newton meter. Okay. Now, for example, usually we use a seesaw to balance to as an example for moments. Okay, now as you can see here, the seesaw is balanced, and the only way that will happen is if the moments of side A, okay, the moments of side A is equal to the moments of side B. To illustrate, for example, okay, if we had another seesaw and we had a weight here, okay, that has 10 newtons, okay, and we had another weight here that is 20 newtons, okay. Now, distance from pivot, 10 newtons, 10 meters from the pivot, okay, 20 newtons, 5 meters from the pivot, okay. So let's compute first for side A, moments of side A, okay? To do this, let's go back to our formula, force times distance. Since we are computing for the moments of side A, okay, let's just label it as a force of side A. So the moments of side A, okay, the moments of side A is equal to the force of side A times the distance from the pivot of side A. That's the only reason why I have an A over there, to tell you that we are computing for the moments of side A. So we need the force from side A and we need the distance from side A. And we are going to do the same thing over here. Moments of side B is equal to what? The force of side B times the distance from the pivot of side B. Okay? So, if you're not clear on that, just rewind a bit and then listen to it again. Okay? So that's the nice thing about the video tutorial. You can listen to it several times at your own convenience. Okay? Now that you know that this is how to compute for the moments of the right side, of side A, all you need to do is to substitute. Do you know what force A is? Yes, it's given. Force A is 10 newtons. So substitute. 10 newtons. Always remember to put the unit, okay? Do we know the distance from the pivot? Okay? We know it. It's 10 meters. Okay, so times 10 meters. So all you need to do is to multiply. So you got 100 Newton meters. Always, always, always include the unit. Okay? Now, let's go and compute for the moments of side B. So do we know the force of side B? Yes. It's 20 newtons. Do we know the distance from the pivot? Yes. It's 5 meters. So just multiply. You end up with 100 Newton meters. So as you can see, the moments of side A is equal to the moments of side B. That is why the seesaw is balanced, because the moments of side A is equal to the moments of side B. Now, how is this going to help you in your computations later on? Okay, for example, you are given a problem. Okay, there is a force of 50 newtons that is, okay, 10 meters from the pivot. Okay, on the other side, there is an unknown force, which is 5 meters from the pivot. What is this unknown force? Okay, go back to what we did over here. You know that there are two sides in the seesaw. So we know this is moments of side A and this is the moments of side B. Is the seesaw balanced? Yes. So what do we know about that? If the seesaw is balanced, then the moments of side A is equal to the moments of side B. Okay? What do we do next? We compute for the moments of side A. Okay? So what is the formula for the moments of side A? It's force of side A times distance from the pivot of side A. Do we know the force of side A? Yes, we do. It's 50 newtons. Do we know the distance from the pivot of side A? Yes, we do. It's 10 meters. So, it's 50 newtons times 10 meters. Okay, which is equal to what? 500 Newton meters. Now let's look at the other side. Moments of side B is force applied of side B times distance from the pivot of side B. Do we know the force applied? No, we don't. That's why we assign a variable. Okay? We don't know what it is. We just give it a variable. You can choose any letter. It can be X, Y, Z, A, B, C. It's up to you. Okay? I just prefer X. So, since we do not know what this one is, I'll just put X, telling me it's unknown. Okay? Now, do we know the distance from the pivot? Yes. It's 5 meters. So it's X times 5 meters. Okay? We can bracket it instead of putting a multiplication sign. So can we compute? No. So just copy it down here. Again, what do we know if the seesaw is balanced? As we said, if the seesaw is balanced, that means the moments of side A is equal to the moments of side B. So what can you say about these two things down here? If the seesaw is balanced, since 500 newtons is the moments of side A, okay, that means this one is the moments of side B. So we know that these two should be equal because the seesaw is balanced. And if this is equal, you can easily compute for your unknown force by doing some algebra. Okay? So, if there's an unknown here, you know from your maths, okay? You need to isolate the unknown. So, you need to leave x by itself. Since this is multiplication, what is the opposite of multiplication? Okay? We need to divide. Okay? So, what do? Divide by 5 meters. Always remember to include the unit. And this one, divided by 5 meters. What you do to the right, you need to do to the left. Okay? You need to be fair. So, this one cancels out. And what can I cancel here? I can cancel the unit. Okay? So, what's left behind? 500 newtons divided by 5 is equal to x. And what is 500 divided by 5? It's 100 newtons, is equal to x. So that means that this x over here is equal to 100 newtons. Okay? X is equal to 100 newtons. So let's see if our answer is correct. How do you do that? You substitute. Okay? You substitute this one into the formula. So you have 50 newtons times 10 meters. Here. 500 Newton meter is equal to x. And what is x? Let's replace it by 100 newtons. Okay? So 500 Newton meters is equal to 100 Newton meters times 5. Is that correct? Let's check. 100 times 5 is equal to 500. Newton times meter is Newton meters. So there you have it. 500 Newton meters is equal to 500 Newton meters. Okay? So that's how to use the principles of moment to look for an unknown. Okay? Try this on your own. What's the answer to this question? If I have a seesaw and it's balanced, okay? This one, there's an unknown force that is 2.5 meters from the pivot. Okay? And there is another force here that is 100 newtons. That's 5 meters from the pivot. What is the unknown weight? Okay? Why don't you solve it? And why don't you send me an FB message with your answer? Okay? So if you have any questions, please send me a message in FB so I can make more tutorials like this. This is Mrs. Nas. Over and out. Have a nice day. Bye-bye.